Hello lovelies, in this video Mr. B is going to be looking at scatter diagrams, taking you through for some easy ones all the way through to some really quite tricky top grade ones. There are lots of examples in here, so copy them down, add them to your notes and then come back to them later when you're revising.
We're going to have a look at scatter diagrams, and we'll start off with plotting scatter diagrams. Now you might have this information in a list or in a table. I have them here as coordinates. So let's start off with the first one. So we're going to plot 2 and 30. Since it's coordinates, x-axis first, go across to y-axis, go up to 30, and draw a little x when you get there. Now this is different to line graphs, where you might do a little dot as you're kind of plotting your information. On a scatter diagram, it's going to be across. Big difference here, on a line graph, you draw little dots and you're going to do dot to dot and join them up. With a scatter diagram, you do not join up the points. Also, it's really important to cross them out as you go. We'll discuss this a bit more in a moment. The next one is 1 and 30. Cross it out, and then we've got 0.5 and 62. So in between 0 and 1 for 0.5, all the way up to 62. Our next data point is 0, 62, across 0 to 62. And the next data point is 9 and 30, so across to 9 and up to 30. Now, the reason why it's so important to be crossing these out as you go is because, unlike line graphs, where the data is in order and you just move across one square to plot your next point, with scatter diagrams, the data is going to be usually in a random order. So you might be moving all over the graph. So it is really important to just do one at a time and not try and rush things and cross them out as you go. Because with a line graph, it's very easy to spot if you've missed one. There'll be a gap in your data. With scatter diagrams, they're randomly all over the place. If you miss one out, you're not going to. So next we have 8.5 and 36. So 8.5 is between 8 and 9, and 36 is in between 34 and 38. Then 2.5 and 50, 6.5 and 42, 8 and 68, and then 9 and 64. And we've now got a finished scatter diagram, and you can see our data points are kind of randomly all over this diagram. Moving on to question 2, we're setting up with 40 and 140, and then we have 44 and 150. Now, a big mistake sometimes on graphs is getting the x and the y coordinates missed out or mixed up the wrong way around. But because on here you can see the data on each axis completely different, the weights are between 40 and 60, the heights are between 140 and 180. It's very hard to get those mixed up. Now, this isn't always true, but for this one, it is. So you're not going to make that mistake and get them mixed up. So going back to the graph, we've got 48 and 146, 50 and 160, 47 and 158. And so the way that I'm plotting this is, as I say the first number, I'm just moving a pen across to it. So when I say 50 for the next one, I move a pen across to 50. And then when I say 158, I'm going from 50 all the way up to 158 and drawing the cross. So then we have 53 and 164, 56 and 162, 56 and 168, and 55 and 176. And what you might be able to see here is that all those coordinates are kind of roughly following a line. There's a couple of outliers at different places, but they're roughly all in a straight line. And for example, you're not going to see any lower weights with higher heights, and you don't see any higher weights with the lower heights. You're either going to see a low weight and a low height, a medium weight and a medium height, or a high weight and a high height. Now, we have a name for this, and we call it positive correlation. And on an exam paper, you are almost always be asked what the correlation of a scatter diagram is. In fact, I can't remember a question where you've not been asked this. And just go through this again. Positive correlation, you're going to have small weights and small heights. You're going to have medium weights, medium heights, and you're going to have high weights and high heights. And you can see all the crosses are kind of following that pattern. What you're not seeing are high heights and low weights, or high weights and low heights. So we're saying there's a connection between height and weight. And what that connection is that taller you are, then you've got longer bones, and if you've got longer bones, then obviously they're going to have a weight attached to them, and you're going to have longer muscles attached to them, and they've got a weight. So you've got more bones, more muscles because you're taller, so you're going to weigh more. It's a positive correlation. Now, going back to question 1, that graph was on the size of TV and the amount of TV watched. Now, that doesn't follow this pattern because we've got large TVs that have very small hours watched. We have small TVs that have very low hours watched. We have large TVs that have lots of hours watched. And we have small TVs that have lots of hours watched. And we've got ones in between as well. So there's no pattern there at all. How big a TV is does not affect how much TV you watch. So what we call this is we say there is no correlation. There is no link between those things. Now let's move on to our next one. So we have 15 and 142, 10 and 146, 0 and 174, 15 and 178, 90 and 142, and another 90 and 142, 35 and 160, 45 and 156, 75 and 178, and we have 95 and 178. Now, another difference between scatter diagrams and line graphs is that you can have more than one piece of data on the same axis. So, for example, we just plotted two things that were on 178 for height. Now, that's normally okay for a line graph having the same thing on the y-axis, but we also have sometimes the same thing on the x-axis as well. So, for example, we had two different data points at 90 on the x-axis, where normally on a line graph you only have one at each point. So you can have repeat numbers in a scatter diagram. Now, thinking about the correlation again, we've got low math test results and low heights. We've got low math test results and high heights. We've got high math test results and high heights. And remember this coordinate down here where we have the high maths test results and the low heights. It looks like one. We did have two identical data points there, so there are 2 points there. And we've got people in the middle. So it doesn't seem like there's any sort of pattern here. So we call this no correlation. How tall you are does not affect how good you are at maths. Just like the size of your TV doesn't affect how much TV you watch. But with question 2, the height you are does affect the weight you are, because you're going to have longer bones and longer muscles, which all weigh more. So if height doesn't affect your math test results, does weight affect your English test results? So I'm going to guess not from the start, but we're going to have to plot it and we're going to have to prove this. So for question 4, we have 5 and 43. Again, notice I'm always crossing these out every time I do one, so don't make any mistakes. We have 0 and 43, 20 and 56, 5 and 58. So notice it's the second point of data that I've plotted at 5, which normally wouldn't happen on a line chart, but it does in a scatter diagram. 80 and 41, 90 and 43, 35 and 45, 65 and 45, 85 and 59, and 85 and 56. So now, thinking about the correlation, we have multiple people which have low results and low weight, multiple people with high results and high weight, but then we've got low results and we've got high weight, and we've got high results and low weight. So again, it looks like there's no correlation. There's no connection between how heavy you are and how good you are at English. Now moving on to the last chart, we have GCSE exam results and we have daily TV watched. So there is a connection between those two things. So starting off with 2.5 hours of TV watched and a score of 95%. Then 1.5 and 65, 2.5 and 70, 5 and 45, 4 and 65, 5 and 55, 6 and 25, 8.5 and 25, 7 and 15, and 9 and 30. So now again, we're thinking, is there a connection between daily TV watched and the number of hours? So just look for patterns here. So if you have a high GCSE exam result, it looks like you're going to have a low number of hours of TV watched. And you're watching a lot of TV, you're going to have a lower GCSE exam result. And then you've got people who are in between. What we don't have are people who don't watch any TV and are getting low results. We don't have people watching lots of TV and getting high results. So what we call this is there is a correlation, but it's not a positive correlation. And you see in question 2, we have a positive correlation, and from left to right, the numbers are getting higher and higher and higher. For this one, from left to right, the coordinates are actually going downwards. So kind of positives going upwards from left to right, going downwards from left to right, we're going to call that a negative correlation. Now, does it make sense, the connection between these two things? Well, if you're watching, 8, 9 hours of TV a day, that's an awful lot of time. And let's say, you are in school for most of the day. That means you're coming home and you're doing no revision because you are watching TV and you're being distracted by it. Whereas people are not watching a lot of TV, they're leaving time to be nice and quiet, focusing on the revision. So they're getting higher results. Now, as well as drawing a scatter diagram, you also need to do something called drawing a line of best fit. We'll talk about what these are used for more in the hard questions, so just trust me for now that they're useful. But there is one thing that I can show you now that will show how they're useful. How do you draw them? Well, what you want effectively is a line that goes through all of your data. Now, a lot of students do this. They draw from one corner to the other corner, and that's not really what you want here. You want your line to kind of go through the middle of your coordinates like this. Now, this little draft line I've drawn, now you'll see I've got 4 coordinates below the line, and I've got 6 coordinates above the line. So that's, again, not really what we go for here. We want equal numbers of coordinates above and below and on the line. So now the line of best fit I've just drawn here, we can see we've got 4 coordinates below the line, we've got 2 coordinates on the line, and we've got 4 coordinates above the line. So the kind of coordinates are kind of evenly distributed around that line of best fit. So that is a much, much better line. Now, you're not always going to get the line perfect. There is a technique that maybe you'll see at A level where you can actually calculate exactly where the line goes. But for GCSE level, you just want a rough estimate. And the one I've drawn is pretty decent. But you could have ones getting the same amount of marks that are kind of slightly tilted above or below it. Again, the important thing is it's got 4 coordinates below it, 4 above it, and the 2 on the line don't count. So it's kind of nice and evenly going through all our points. Now, the useful thing about this is that pink line is going upwards from left to right. So that's telling you straight away that it's positive correlation. Now, to be really clear here, if you're asked to draw the line of best fit, you don't need to write down what the correlation is. It's not part of that question. But almost every single question I've ever seen, they're pretty much always going to ask you for the correlation as the question after it or the question before it. So I'm just going to put this in as an extra piece of information. Moving on to question 2. So I'm just going to have a kind of guess first and draw a line roughly going through. Then I'm going to double check it. And I think, right, okay, I've got 4 coordinates above my line. 1 or 2 are kind of on it, and then I've got 4 below. So it's not a bad first try, but the 2 coordinates that are actually on the line, they're not quite on the line. So I think I'm going to move this line a little bit further down. So now I've got a much better line where those 2 coordinates are exactly on my line, so I'm not going to count those. And I've got 4 above and I've got 4 below. I've got 1 above that's really close and 1 below that's really close, and then about 3 others that are further away. So that's looking like a nice even line of best fit. Now you might think to yourself, hang on, do I need to draw this rub it out and draw this rub it out? Well, the way you're going to do this is you're going to use your ruler to kind of judge it. You put your ruler on the page, and maybe tilt your ruler so the edge is facing you, so you're not covering up the diagram. You can move your ruler around until you judge it perfectly, and then you draw your line. So you're only drawing it once. Now this line is going downwards from left to right, so this will be a negative correlation. So you'll see we're actually judging if it's positive or negative much more quickly than we did in the easy questions, where we kind of use a bit of logic in all the different points, because we can just see the shape of the line. Now, what we're saying with these correlations is for question 1, there is a positive correlation between umbrella sales and rainfall. That's basically saying the more rain there is, the more umbrella sales there are. The less rain there is, the less umbrella sales there are, which kind of makes sense. For the second question, a negative correlation, we're saying there's lots of rainfall. There's not lots of ice cream sales, it's the opposite way around. It's not lots of something and so lots of something else. And there's lots of rainfall and there's not a lot of ice cream sales. So one thing is high and one is low. On the opposite end, if there's not a lot of rainfall, there are much more ice cream sales. So if both variables are going up, it's a positive correlation. If one goes up and one goes down, it's a negative correlation. Now moving on to question 3. Again, put your ruler on the page and just have a rough guess to start. Once you put your ruler on, just have a look at what you've got. So I've got 3 coordinates on the line of best fit, 3 above and 3 below. So actually that's a really good first try, and I think I might actually keep that. Now it looks a bit different to the others, but it's still a positive correlation. From left to right, it is going up. Now, in question 1, the positive correlation went all the way up to the top of the graph, where in this one, it's going about halfway up. Now, there's nothing to do with the data about that. That's just what axes have been chosen, specifically the y-axis. If my y-axis only went up to 50%, then you'd have something that looks a lot more like question 1. Now moving on to question 4. So again, I'm going to have a bit of a guess at this first, and then we'll see how well I've done. So I've got 2 coordinates below the line of best fit. I've got about 4 above it and about 4 on the line, so I can probably adjust this a little bit. So what I want to do is probably raise it up a little bit and maybe even change the angle of this. So rather than start at 30, I might go down and start at say 28 and see how that looks. So now look at the next try. I've got about 5 coordinates above the line of best fit. I've got about 3 below it and 2 on the line, so it's not a great guess. Now there is a problem here in that the lines that are above are all at the start, and the lines that are below are all at the end. And what that means is the rotation of this is wrong. Now, it's actually worse than the last one. So I think what I might do now is rather than starting at 28 or 30 like the last 2 tries, I might actually have my line go higher up. And so with the line that I've just drawn now, you can see the coordinates that are above and below my line of best fit are much more evenly distributed throughout the line. It's not all one at the start and all the other at the end. Now look at this, I've got about 3 on the line, I've got about 3 above, I've got about 4 below. Now I could probably adjust this a little bit more, but I'll probably leave this as it is. It's pretty close, so I should be getting that as a right answer. But maybe what you could do with the ruler is just rotate it kind of downwards a little bit, and if you just move the top of the line down a bit, a millimetre, you should get that absolutely perfect. What you can see though is this is a negative correlation. Now we're talking about the temperature and electricity used. So if there's a high temperature, less electricity is being used, and if it's a low temperature, more electricity is being used. So you think about things like if there is a higher temperature, you don't need as many heaters on, so you don't need the electricity for that. And indirectly, if it's a higher temperature, then you might think there's maybe more sunlight to create that temperature, which means you don't need the lights on in your house as much. So an interesting thing here is a variable that's not on the graph is connected to it. High temperature because more sunlight, and it's actually the sunlight that's the main factor in the electricity being used being lower, because more sunlight, less lights on your house. Now moving on to the last one. So we have a correlation between English test results and maths test results. So again, I'm just going to have a go at putting this in. And have a look. Now I've got about 3 coordinates above the line, about 4 below it, and about 2 on the line. So that's a pretty good start, probably good enough to leave. And we can see we have a positive correlation. If you are better at English, you're going to be better at maths. If you're worse at English, you're going to be worse at maths. They are connected. So that might be something like, if you're really good at English, you're good at reading information. So in your maths lesson, you can read information off the board, out of your textbook, much more easily. Or just general study skills. If you're revising hard for English, you're probably also revising hard for maths, so there'll be a connection there. Whereas if you don't do your homework in English, maybe you're not doing it in maths either. So you've got a connection there as well. Now, as well as line of best fit being a good way to kind of tell the correlation of the graph, it's also something we can use to make estimates. So whenever you're asked to estimate something, always draw your line of best fit first. So for question 1, I'm going to try and draw a line of best fit. The same logic as before, so I've got about 3 coordinates below. I do have about 4 or 5 above, but they're pretty close to the line, closer than the other ones. So I think that's a decent line of best fit. Now it says estimate the electricity used when the temperature is 21 degrees Celsius. So that 21 is the key. We're going to find 21, and the degrees Celsius is also important. It's going to be 21 on the axis that says degrees. So I've just marked on where 21 is. And what you do is you continue the line that 21's on across. Make sure it's parallel with the x-axis, and I've hit the line of best fit. Once you've hit the line of best fit, you then need to go downwards. Again, make this line parallel to the y-axis. And I'm hitting around about 7 there. And I can write that as my answer. 7, and then use the units, kilowatts per hour. Now, I do actually think that my line was a little bit lower than 7, so I could have said something like 6.8, 6.9. But the other thing here is the line of best fit isn't certain, and other people are going to draw the line of best fit slightly differently, and that'll mean your estimate will be slightly different. So when I'm saying my answer is 7, I'm not saying that's the absolute accurate answer, but what will happen is your examiner will allow you a range. So the exam might say, if the student has an answer between 6 and 8, they're going to get the right answer. So my 7's probably going to be somewhere in the allowable range, and that's fine. So don't agonise too much for getting it absolutely perfect. you are going to be allowed a range of answers. Moving on to question 2, the first job is to draw a line of best fit. Once you've drawn it, always double check. So I've got about 4 coordinates above, about 5 below, and 1 on the line. So that's pretty even. I'm allowed a range. I don't need it absolutely accurate. We're looking at 166 as our clue, and that's in centimetres. So we're going to find the axis for centimetres, that's the y-axis. We're going to find 166. That'll be between 164 and 168. We are going to move the line across. And when we hit our line of best fit, we're going to move downwards. And I'm hitting 8. Estimate the shoe size. It's going to be a size 8 shoe, roughly, if you're 166 centimetres high. And again, that's an estimate in the first place, so don't worry too much. Again, the exam might say something like anything between 7 and 9 would be an acceptable answer. And you'll notice as well, question 1 was a negative correlation and question 2 was a positive correlation. And it was exactly the same method for both. Now looking at question 3, I'm going to draw a line of best fit. I'm just going to check it. So I've got about 5 above and 5 below. But I'm not happy with this because it's much closer to the 5 above than the 5 below. So I'm just going to delete this line and have another go. So this time I'll draw a similar line, move it a little bit closer to the coordinates below. And that now should be closer. So now I'll look at my estimate, identify the numbers in the question first. We have a 6, and it's talking about the price of a car is 6. I'll find a 6 on the price of a car axis. There it is. And that's £6,000. So we're going to move across to our line of best fit. When we hit our line of best fit, we're going to go down. We're going down in between 3 and 4. So in between 3 and 4 will be £3,500. So £3,500. I've written that in kind of more traditional units, but you could just write £3,500 and use the same units the question gave as well. Moving on to question 4. Again, line of best fit first. Just double check it makes sense. I've got 5 below the line. I've got 6 above the line, but they're a little bit closer, which will cancel it out. So that should be a decent line of best fit. Let's identify what the question says. 164 centimetres. So let's find that. That is on the y-axis again. And now I've drawn a dash at 164. I can continue it across to the line of best fit. Go down once you hit it, and I'm hitting 50 kilograms. Remember to use the units. A common mistake might be reading from the wrong axis. Not possible with this one because the numbers don't match, but for some of them they do. Now moving on to the final question. So again, our first step is a line of best fit. Now again, please don't do this and draw just all the way across. You can see that most of the coordinates are actually above that line. There isn't a connection between the line of best fit and 0, 0 on any of these axes. It does not necessarily go through 0, 0. Although it will sometimes. And so our new line of best fit follows the points much more closely, going through the centre of those coordinates.
Ouch! This is why in some videos I have explained scratches.